Hey, welcome to our video podcast about AI and its practical use in business. I'm Bas, joined again by Koen. And today we're excited to share something we've built in the real world during one of our POC builds. POC is a proof of concept that we built within a week. It's a custom tool we've developed for COA, the Centraal Orgaan Opvang Asielzoekers, which is the Dutch central agency for the reception of asylum seekers. And we'll take you inside the solution and show you what we created for their real estate department and their facility management department. That tackles a common problem, which is finding the right information quickly across thousands of documents, possibly. And we built an augmented rag agent that does a search in a vector database with a pre-selection of which documents to pull information from to reduce the context size that comes back during this rag phase. I'll explain some of the terminology a little bit later together with Koen. But if it sounds too technical, we'll be sure to inform you about all these terms during the demo.
Yeah.
And I think this is a perfect example of how you can solve practical everyday problems, even in government organizations where you have all these documents everywhere. Yeah, so maybe we should start with the terminology quickly. Like I mentioned a few of those.
Yeah.
Like, for example, a rag. Maybe you want to quickly explain what it is.
Explain rag is. Yeah, because you said augmented rag, right?
Yeah, that's what we call it ourselves.
Yeah.
Like it's an augmented way of...
Yeah. But RAG stands for Retrieval Augmented Generation, and it's a technique to store your business information in a specific type of database, which you can link to an AI model without putting this business information inside the actual model. So it's an easy way to unlock your business information in combination with an AI model. I'm not sure if it's the right moment to explain how it technically works. Do you want me to explain it as well, or?
Well, why not? In a couple sentences.
In a couple of sentences, okay. So we have this RAG setup, this Retrieval Augmented Generation, which means that all the documents you have in your company, so let's say, for example, policy documents, we parse them to store them in this special database, and we parse them by giving them an embedding in a vector space. And an embedding is an actual 3D location in a vector space, which you need to plot it in your mind like a 3D world. And these positions in this vector space are based on similarity, textual similarity. So it's a semantic similarity between texts. Every piece of text of a document has this embedding in this vector space. And then when, as a user, you ask a question to the AI, your question is also given this embedding in this vector space. So it's like a dot in this vector space, and then you can say, give me the 10 closest documents within this vector space next to your question, which might have the relevant information in there to answer your question. So it's like a 3D representation of the text you have based on similarity. And your question is then put in this 3D world to then look for the closest relevant text to answer your question.
I have to say, very well explained, right? Because we didn't prepare for me asking this question to Koen, but I think if this is your top of mind answer, it's very good. Nice.
Thanks.
Yeah, but maybe then we should dive a little bit into why we, or at least me, calls it a improved RAG model.
Yeah, but maybe first we need to, because I wasn't involved with this POC. So I'm also curious about the problem they had when they came to us.
Right. Yeah. So
before we explain why we made augmented rag.
Yeah. So this immigration service or asylum seeker service is really hosting a lot of asylum seekers, and therefore they have a lot of property in which they do this. And of course they have to manage this property according to regulations, according to other specific local rules that might be applicable to those locations. And this is what the real estate and facility management department does within the organization. And they have a lot of people around managing all these contracts for these locations. And these contracts are contracts that have been made with third parties that do, for instance, some maintenance on those locations, but also internal documents or indeed regulatory documents that lots of people have questions about. For instance, when a third party wants to do maintenance at a specific location, it's really hard to figure out, okay, what does this person exactly need to do in the end? Or what specifically did we discuss and put into the contract 3 years ago when we did the negotiations with this third party? And traditionally, this has been very hard to find out, and they have a whole department answering questions about all these contracts all day. So that's everything they do.
Yeah, and when we talk about contracts, are we talking about PDF files, Word documents? What types of documents do they use?
Yeah, it's mostly PDF files, so the contracts, but it's also Excel files, but it's and some other formats like scanned documents, etc.
And where do they store these documents?
They all store it on a network drive somewhere. So they have the Office suite, and they have shared drives where they store everything. So if they want to find a certain contract, first they have to know in which folder to look.
Yeah.
And then dive into the contract and then read the whole contract and then make a decision or part of the contract where they think they can find the information to answer a question from a user or someone at the COA. But yeah, that's very time consuming. So then we proposed to them that they could use this RAG kind of approach to ask questions to their contracts or about their contracts, or even questions that are about multiple contracts at once. And of course, we had some recent developments in AI where you even have reasoning models that can really figure out very complex questions and know where to look in this RAG database or what kind of queries to do to the RAG database to make sure the right information gets returned. And of course, our expertise also helps to steer the model somewhat. And I think the technical problem we had to solve here is that a traditional RAG database works in a way where you ask a question or where you have a question and then the relative position of context is calculated over the entire database. And then you might end up with embeddings or pieces of the vector database that might not be as relevant for the specific contract or contracts you're asking questions about. So we needed to find out a way to pre-select where the AI model can search in. So if you have a question about location A and location B, information from location C might not be relevant at all. But yeah, if you don't do any pre-selection or filters, it could be that some text from location C is returned to the AI model before your question gets answered. And that was a technical problem we also had to solve. So yeah, the plan is to show you how we've done that.
Yeah, but to sum up, so Augmented Rag is some sort of smart filtering of the RAG database then.
Yeah.
Maybe you need to show how it technically works, but
yeah, I can. Maybe you can quickly explain in which kind of tool I'm going to show it, because it's going to be n8n, and let me pull it up on the screen and then.
Yeah, sure. Yeah, we're using n8n, which is a low-code flow builder in which we can build automations like Bas is going to show in a minute. And the cool thing about n8n, it's an open source tool built by the community as well. So there are a lot of integrations with existing systems like Microsoft Teams, SharePoint, Google. And they also have cool integrations with all the larger AI providers like OpenAI, Anthropic, etc. So this is the main tool we use when we do a proof of concept.
Yeah, and in this case, the proof of concept consisted of 3 different parts. The first part is getting all the documents from the organization into a vector database. So this is what we call the ingest flow. Then we have a part where then we have a knowledge base, which is basically the retrieval of documents from that knowledge base. And then we have an AI agent managing the connection to the tools, but also making sure messages can be sent to it and then returned to a chat client. So actually, if we include the chat clients, it's 4 different parts that work together to provide the user with an interface that's just a chat client where they can ask questions about all these contracts. But maybe first start with the document selector, which is actually the augmented part of the Rag application. So over here, we have a very interesting flow where, for this proof of concept, we work with Google Drive. So not directly with their network drive, but we pull all their contract files from Google Drive that are relevant. So they uploaded it themselves. And then we go over all those items and see if we have already ingested it. So that's basically the first part, which is not that relevant. But before we are going to put stuff in the vector database, we are asking an AI model, in this case Gemini from Google, to summarize each of those documents. And so we can later tell the AI model what's more or less in the document. So we can do the predefined filtering, which I will show a little bit later. And here is room for optimization in terms of how we save the summary to the database, because it could include more specifics, less specifics. Now it's basically 3 sentences about what kind of information can be found in these contracts or documents.
But that summary is used by the AI only, right? It's not used by the user.
Yeah. And we even had a discussion about it this morning, that it shouldn't necessarily be a summary that's humanly readable. But right now it is, because it's just what Gemini writes by default. But we could optimize that a little bit. And we actually use those summaries to tell the AI model which filters to use later in the process. But I will get to that a little bit later. So we create the summary and we'll put the entire document into the vector database. And then at the moment we do this, it's actually chunked into pieces, and metadata is added to these small parts of text. And the metadata includes the summary for each part of text, but also a lot of other metadata values like page number and document name and all kinds of other stuff that might be relevant to answer questions about that part of the text. Then over here on top, we have a tool that AI can use. This is the knowledge base retrieval tool. And here we're actually pulling the summaries we put into the vector database. So that happens here in the first part. Actually, we can see, it's quite technical maybe, but we're doing a query to the database, and we're basically saying, okay, give me all the file names, but also give me all the summaries. So we get a list returned of all the documents that are in here. And now I'm not showing you executions right now because they might contain some privacy sensitive information, but you get a list of file names and what those file names or documents include.
And maybe, sorry for interrupting, but when is this flow called?
Yeah, by the agent, which I will show a little bit later.
Okay, yeah.
So these are both the knowledge base creation and the knowledge base retrieval. So we're now looking at the retrieval part, and we just looked at the creation part, so to say. And then we're having all those summaries and file names together, and then we ask an AI model, okay, look at this list of files and summaries and pre-select for us which documents might be relevant for this particular question. And then if we get a list of documents, we look through each document and retrieve some specific context for those documents specifically. Why this is better again is because we really drill down into the contracts that the question is about and make sure no other data that might not be relevant at all is returned by this knowledge base retrieval, which can happen in a normal situation. And then we return the answer to the agent. So let's maybe now go to the agent so we can get the full picture.
I do have one question about this flow.
Yeah.
So we select a list of relevant documents and then we do the rag like a normal rag, right?
Yeah, for each document.
Yeah, so it's for example, when the document selector finds 3 relevant documents, we actually do 3 rounds of RAG, Retrieval Augmented Generation. And then based on these set of information, we hand it back to the agent to answer the question.
We pass like the chunks of text from those 3 documents, but an X amount of text per document.
Yeah.
And right now in the POC phase, we didn't optimize for token usage, for instance. So this flow still takes a lot of tokens, which lead to higher costs, of course. But there's room for optimization here. So, for instance, wait, that's the wrong note. But we're now saying, okay, from each document, get 10 chunks of text. And those chunks of text are also relatively high. But what you can see over here is that we are filtering on those file names that the AI came up with in an earlier step to make sure we only look into that information. And it works really, really well in this case because the questions or the answers are super accurate. And we had some problems in the past as well with hallucinations or chunks of text being returned while not at all relevant for the particular question. And over here we have the agent, and the agent is connected with the chat client. So the chat client has a question gets sent to this webhook from the chat client, and then in the end, the AI returns an answer. So that's what these 2 nodes mean. And in between, we have an AI agent, which is a tools agent, which is a specific agent that can really use all kinds of tools and is specialized for that to call them in the right format and get the least amount of errors and retries doing it. And in this case, we connected Anthropic to as a model, and basically that's the intelligence of this agent, and the agent can take multiple steps and do multiple calls also to the knowledge base if it thinks it needs more information, of course, but usually it does 1 call, and then the knowledge base tool is actually the retrieval knowledge base flow that we've seen in the previous workflow. And then we also include some other data. So we include some source data. Where's the data coming from? And this is a code block to strip some of the text from or some of the parts of the AI response. So we can also show that in the chat client separately. So people can click a button, I want the source of these documents, where you based your answer on. And then we are able to show that in the chat client as well. So yeah, that's basically it.
Nice. But for a POC, it's quite a lot, right?
Yeah.
It looks like a complete version, or are there still any further developments we would like to do?
Well, we have a whole list of feedback, and eventually this agent now lives in a separate chat client on a dedicated URL.
Yeah.
But the idea is that we are going to integrate this in their Teams environment or a tool they already use, like their intranet, or where people ask questions, maybe in their service desk tool, where they get incoming tickets about all these contracts. Yeah, quite an extensive POC. But we built upon something we already did in the past. So we already built this kind of document pre-selector flow for another customer. And therefore we could start there and then improve, like work towards the improved kind of model where we dynamically make all these summaries per document and then also retrieve those from the database again. And the cool thing is that it's really scalable now. So we can put all of our documents in that Google Drive, and then 15 minutes later, the knowledge is in. And the customer can do this themselves, even within this POC phase.
And then what kind of limitations do we have in terms of the amount of documents or type of documents?
Right now we have our Google Drive storage. So that's a limitation, but quite some room left. But another limitation is that we're right now only parsing PDF documents and specifically the text from the PDF documents.
Yeah.
So what we want to do after the POC phase is also explain images that are within the PDF documents. So we can also ingest those in the document database or in a knowledge base. And we also had scanned documents, which are now ignored. Ignored. So we now only work with PDFs that have text. With both flows, we already have a working direction for. Just take some time to make the right exceptions in our flow to also support those kind of documents. So yeah.
Nice.
I think very interesting. And we had a whole discussion with the team about this, right? Is this really better than the normal rack, or do we get increased performance? Feeling wise, for me at least, it's a lot better than what we usually get if we do a traditional rack kind of flow without the document pre-select filters. But we have yet to do an extensive research with it.
Yeah.
But so far, the client is really impressed with the answers.
Nice. And would you say that this setup, is this really specific for contract management, or can it be used in a more broader application?
I think even in a broader configuration, and also with other types of use cases mixed into it. Because usually if you have different types of use cases, it's really hard to filter for a specific department, for instance. But because we now have a summary and this file list for all the documents, the AI can already drill down into what's relevant for someone from a specific department, for instance, instead of searching the whole vector database or the whole knowledge base that's organization-wide, which is quite cool, I think.
You mean that we, in this contract database, we're also going to add, I don't know, product information, which is a whole different set of use case, different information. We put it in the same database. And then based on the document pre-selection, you prevent it from conflicting with each other.
Yeah, exactly.
Yeah. Nice.
So automatically scalable, I would say.
Yeah.
Yeah, so that was my quick demo. Do we have any more on the agenda? I think that this was quite...
Yeah, I think this was the things we would like to do today.
Yeah. So yeah, I would say thank you everyone for listening to us again and watching this video. It might be more useful to watch it on YouTube this time because it's quite a visual presentation.
Yeah.
But yeah, follow us, subscribe to our channel so we can post more of these videos. Thanks a lot. Leave your feedback if you have any.
Yeah, see you next time.
Yeah, thank you, Koen.
You too.